Next, we're going to talk about the domain of a logarithmic function and how you come up with it from the equation, okay? So think back to section 3.1 where we spent a lot of time on domain. We had rules to get the domain of a function from its equation. So for example, if we were dealing with the domain of a polynomial, it's going to be all real numbers. If we were dealing with a fraction, we had to find the bad spots. So we had to figure out what made the denominator equal to 0. So we set the denominator equal to 0 and solve to get the bad spots. And the domain then would be all real numbers except for those bad spots. Okay, if we were dealing with a square root function, the rule was to take what was under whatever is underneath the square root and set it greater than or equal to 0, and then that's your domain. Okay, so now this is another domain rule to add to your domain arsenal. Okay, so here we go. This is something you absolutely have to know. Look at this red statement here, okay? We can only take the logarithm of positive numbers, okay? That is, we cannot take the logarithm of any negative number or of 0. Very, very important statement. We cannot take the logarithm of any negative number or of 0, okay? Doesn't matter what base I'm dealing with, okay? So you can see this if you get your calculator out, okay? Maybe you're just kind of looking at this. Hold on, let me get the lighting, okay? Hang on, let me turn this off. Whoops, that did not work. Okay, so if I took, let's say, I don't know, let's do log here. Okay, so let's do log. Okay, so this is base 10. So if I did the log of 0, I'm going to get an error message. Okay, if I did the same thing, but with natural log, same error message. Okay, you absolutely cannot take the logarithm of 0. Okay, so now if I tried a negative number, okay, I'm just making up a negative number. So let's say log of negative 26. Okay, you're going to get an error message. Okay, same thing with the other base. Okay, any other base. Okay, so you've got to remember this. Absolutely cannot take the logarithm of a negative number or of 0. Okay, so that very much comes into play when we're finding the domain of a logarithmic function. Okay, so basically this is what you're going to do. Okay, here's your rule for finding the domain of a logarithmic function, no matter what the base is. Okay, here it is. Okay, take the quantity you are taking the logarithm of, and set it greater than 0. Okay, solve, and then that's your domain. Okay, so the rule for logarithms is very, very similar to the rule for square roots. Okay, the only difference is if you're dealing with a square root function, you're going to set it greater than or equal to 0. With logarithms, because you can't take the logarithm of 0, you have to set the quantity strictly greater than 0. Okay, and we're going to go back for a second before we actually do these problems. Okay, take a look at the last example when we did this. Okay, so we did these graphs and then we observed the domain in each case. Okay, but if I go back and I take a look at this, so let me see if I can find a different color to put this in. If you go back and you look at this, we can kind of see that our rule for the equation is true. Okay, we basically came up with the graph, wrote down the domain from the graph. But watch, if you go back and do this with the equation. Okay, so if I was doing this one, okay, log base 2 of x, okay, you're going to take the quantity, okay, that you're taking the logarithm of. Here I'm taking the logarithm of x, okay. I am going to set, according to the rule, set that quantity bigger than 0. Okay, so this tells you your domain, your x values have to be bigger than 0. That corresponds to this. Okay, so then watch this, okay? So here we go. This graph, okay? We know this is this domain, okay? The rule is whatever I'm taking the logarithm of. Here I'm taking the logarithm of x plus 3, okay? Don't care what the base is, okay? To get the domain, I'm going to take that quantity and set it greater than 0. Strictly greater than, not greater than or equal to, okay? Solve this. So move the 3 over. You're going to get that your x values have to be bigger than negative 3, okay? Same thing. That's what we observed from the graph, okay? All right, so one more. When we looked at the last transformation here, okay? Again, the equation was a little more complicated because it had 2 transformations here, okay? But again, all of this -1 to shift down is just noise, okay? Whatever I'm taking the logarithm of, it's still x plus 3. I need to set it greater than 0 and solve, okay? So I end up with the same domain, okay? So that's all you have to do, okay? Whatever you're taking the logarithm of, you need to take that quantity and set it strictly greater than 0. Solve, that's your domain, okay? So in example 6, you need to find the domain of each function, okay? So in part A, we've got g of x is equal to the natural log of x minus 1, okay? So all you do here, okay, the quantity that I'm taking the logarithm of is x minus 1. We're going to take that and set it strictly greater than 0, okay? All right, and then we're going to add 1 to both sides, okay? And we're going to get x is bigger than 1, okay? So this is saying you can only plug in x values that are strictly bigger than 1, okay? You can convert this to interval notation. So remember, if you want to draw a little number line here to take care of the x values that you're looking at, 1 is the spot we're interested in. You cannot be 1. Okay, notice you cannot be 1. If x is 1, you're going to get the logarithm, natural log of 1 minus 1. You're going to get the natural log of 0. That's bad. Okay, so we can't be 1, but we can be anything bigger than 1. Okay, so your domain is going to be from 1 to infinity, not including 1. Okay, and like I said, it makes sense. You can check points. Okay, if I plug in, 5 is a number in this interval. Okay, so if I plugged in 5 for x, okay, that's doable. Okay, watch. Okay, I would have the natural log of 5 minus 1. Okay, yes, the answer is going to be messy, but I'm not going to get an error message. Okay, if I pick something outside of this interval, something not in the domain, so -6, okay, for example, okay, logarithm, if x is -6, plug that in, okay, you're going to get an error message. Can't plug that in because you would end up, if you plugged in -6, it would be the natural log of -6 minus 1, that's the natural log of -7. You can't take the logarithm of a negative number, so it wouldn't work, okay? All right, so that's what's going on here, okay? All right, so let's keep doing this. I think we have a total of 4 of these. I'm going to jump to part C because it's similar to part A, okay? Parts B and D are a little tricky, so we'll save those for after, okay? All right, part C, okay? I have this logarithm right here. It's another natural log. I'm taking the logarithm of 2x plus 3, but I have some noise here. I've got the logarithm multiplied by 5, and then we're adding 8 to the whole quantity. So it looks like there's a lot going on, but you're still going to do this the same way. I call this 5 and the 8 noise. Okay, it's trying to trick you. All you have to do for domain, whatever I'm taking the logarithm of, I am going to set it strictly greater than 0. Okay, you don't have to worry about the rest of the problem, only what you're taking the logarithm of. So solve this. So we're going to subtract 3. We're going to get 2x is greater than -3. Okay, divide by 2, divide by 2. You get that your x values have to be bigger than -3/2. Okay, so again, you can draw your little number line. Okay, you're interested in -3/2. Okay, can't equal that number, but you can be anything bigger. Okay, So your domain is going to be go from left to right, write what you see on the number line, okay? We're starting, our leftmost point is -3/2. We can't equal that, okay? And then we go off to positive infinity, okay? That's it, okay? So you didn't have to, the 5 didn't come into play, the 8 didn't come into play. You're solely concentrating on what you're taking the logarithm of, okay? Just to kind of re-emphasize, remember, you are dealing with an inequality here, okay, because you're taking the quantity and setting it greater than 0. So remember, if you're solving something and you do multiply or divide by a negative number, you are going to have to flip the direction of the inequality symbol. So don't forget that if you encounter it, okay? All right, let's go to B now. So like I said, B and D are a little more complicated. So let's take a look at them, okay? All right, so in part B, f of x is equal to log base 2 of x squared. Okay. All right. So let's kind of think about this. What can I plug in for x and be okay? Okay. So I am squaring my x value. Okay. So let's try some things. I am going to plug in some positive numbers. Okay. If x is 1, I would get log base 2 of 1 squared. That is going to be log base 2 of 1. Okay. And I'm not worried about what I'm going to get, what that number equals. That number is actually equal to 0, okay? But I'm not so much interested in what I get as the value. This is doable, okay, because I'm taking the logarithm of a positive number. So that's good, okay? I plug in x equals 2, log base 2 of 2 squared. That's going to be log base 2 of 4, okay? Again, it's good because I'm taking the logarithm of a positive number. Okay, and you can keep trying various positive numbers. They're always going to work. Oops, should be log base 2. Okay, this is going to be log base 2 of 9. Okay, again, I'm taking the logarithm of a positive number. So positive numbers work. Okay, you can plug in any positive number for x, okay, and be okay. All right, so if I did the same thing with negative numbers, okay, so I'll just try some. Log base 2, if I plug in x equals -1. So let's try that, okay? So let me write it this way. So if we have x equals -1, okay, plug that in, I would get log base 2 of -1 squared. And since I'm squaring the -1, -1 times -1 is +1, I'm still taking the logarithm of a positive number, okay? And if I tried a couple more, this is always going to work, okay? If you plug in -2, you square that. -2 times -2 is +4, okay? You're taking the logarithm of a positive number. You're good here, okay? I'll go ahead and do -3, okay? You plug in -3 for x. So log base 2 of -3 squared, that would give you log base 2 of +9, okay? Again, not interested in what this answer is, okay? This one's 0. These two are going to be, well, no, this would be 2. This would be some messy decimal. Again, I don't care what the actual number is for the logarithm. I just need to know I can do this. I'm taking the logarithm of I'm taking the logarithm of a positive number, so I'm going to be okay. So, I can plug in positive numbers. I can plug in negative numbers. So what's left to check? 0. Okay. What happens if x equals 0? Okay. Plug in x equals 0 here. So we're going to get log base 2 of 0. Okay. Well, remember, big red statement. You can't take the logarithm of 0. Okay. So can't do this. Okay, that's bad. Okay, so your domain here is going to be all real numbers except for 0. Okay, we were fine plugging in positive numbers. We were fine plugging in negative numbers, but we cannot plug in 0 because we will end up taking the logarithm of 0. Okay, so the domain, so remember if we draw the little picture here, okay, 0 is the bad spot. But we can plug in positive numbers. We can plug in negative numbers. Okay, so our domain here is going to be all real numbers except for 0. All right. Last one. I know this one was tricky, okay? As long as you're comfortable with doing something like A or C, you'll be good, but I did want to show you a couple of more challenging examples, okay? So let's take a look at part D. Okay, so here's part D, okay? And the reason this one's a little more difficult is because now we not only have a logarithm, but we have a fraction involved as well, okay? So first of all, remember when we did section 3.1, we had problems where we had you had to find the domain of a fraction and a square root. You had both in the same problem. So this is going to be another combo problem, okay? This time you have a logarithm and you have a fraction. So you have to kind of deal with those issues separately, and then you have to pool the results, okay? So first of all, I will deal with the logarithm. So we're just going to look at the natural log here, okay? So first thing I'm going to do is deal with the logarithm, okay? So my logarithm is natural log of x, okay? What can I plug in for that? Well, my quantity, whatever I'm taking the logarithm of, has to be greater than 0, okay? So that has narrowed things down a lot, okay? So I'm going to start drawing my picture, okay? My x value that I'm interested in is 0, okay? X cannot be 0, okay, because you would end up taking the natural log of 0. That's bad, okay? All right, so it can be anything bigger than 0, okay? So that's what we get from the logarithm condition. But now we've got to look at it from a fraction perspective. Okay, so remember, with a fraction, what gets you in trouble? Well, if you divide by 0. Okay, so we need to figure out the bad spot. Okay, the bad spot is when the bottom is equal to 0. Okay, you can't divide by 0. Okay, so you need to figure out what makes the bottom 0. Okay, so all you got to do, and this is a great intro to the next topic. We're going to start solving logarithmic equations. This is a logarithmic equation where you have an equal sign and you've got a logarithm, okay? All you have to do is think arrow thing, okay? The base of this logarithm is e because it's a natural log, okay? So I'm going to go ahead and write in my e, okay? And then do the arrow thing. E to the 0 power is equal to x, okay? Anything to the 0 power is 1, so e to the 0 power is 1, so your bad spot is 1, okay? So if you think about that, okay, like take your calculator, check it out, okay? If I did 1 divided by the natural log of 1, okay, you're going to get an error message because you're dividing by 0, okay? That was actually one of our logarithmic properties that we talked about when we first looked at natural log. I'm trying to find that piece of paper for you, okay? Remember, natural log of 1 is 0, okay? All right, so x equals 1 is a bad spot. You cannot plug it in, okay? So from this second condition, the fraction condition, you need to go adjust your picture, okay? 1 is a bad spot, okay? So we have to put an open circle here, okay? So let's do this, okay? So, okay, so basically, here's the picture of what x values we can plug in, okay? We can plug in anything bigger than 0 with the exception of 1, okay? So go from left to write down your domain, okay? We're starting at 0. X cannot be 0, okay? And then we travel all the way to 1, okay? So you can plug in any decimal number between 0 and 1 and be okay. 1's a bad spot, so you've got to get rid of it, okay? Pick up on the other side of 1, and then you can plug in anything bigger than 1, okay? So that was another tricky one. There's the domain. All right. So like I said, the next topic will be solving logarithmic equations. It's not bad because all you have to do is the arrow thing.